Let's break down TPM, Trusted Platform Module, and GPT, Guide Partition Table, Partitions. TPM is a hardware-based security module that is used to enhance the security of a computer by providing encryption and protecting sensitive information, like encryption keys and passwords. It is a small chip, usually integrated into the motherboard, that works with the system's software to perform security-related functions. Key features of TPM include hardware-based security, which provides physical isolation of sensitive data from the rest of the system, making it harder for malware or unauthorized users to access or tamper with it. It securely stores encryption keys, such as those used in BitLocker encryption in Windows or other disk encryption solutions. TPM helps with secure boot, ensuring that only trusted firmware or operating systems are allowed to run, protecting against bootkits and rootkits. It can measure and verify system integrity, checking whether system files or firmware have been tampered with. TPM is also used for strong authentication, providing a secure method for users to authenticate to a device using biometrics, PINs, or passwords. Use cases for TPM include BitLocker, a disk encryption tool in Windows that uses TPM to securely store the encryption keys. Windows Hello, a biometric authentication method for logging into Windows using facial recognition or fingerprints, and Secure Boot, which ensures the OS and firmware haven't been tampered with by checking digital signatures. Now let's discuss GPT, Good Partition Table. GPT is a modern partitioning scheme that replaces the older MBR, Master Boot Record, partitioning system. It defines how data is organized and stored on a storage device, such as a hard drive or SSD. Key features of GPT include larger disk support, as it supports disks larger than 2 TB, making it ideal for modern drives. GPT allows for up to 128 primary partitions, depending on the OS, without needing to create extended or logical partitions like an MBR. It stores multiple copies of the partition table, both at the beginning and the end of the disk, making it more resilient to corruption or data loss. GPT includes CRC protection to verify that the partition table has not been corrupted and is part of the UEFI standard required for booting UEFI-based systems, unlike MBR, which is used with legacy BIOS systems. When comparing GPT and MBR, MBR is the older partitioning scheme that supports a maximum of 4 primary partitions and disks, up to 2 TB, becoming obsolete in favor of GPT for newer systems. GPT is modern, flexible, and more robust, supporting larger drives, more partitions, and is needed for systems that use UEFI instead of BIOS. An example partition layout with GPT includes the EFI System Partition, ESP, which is a small partition used by UEFI to store boot files, primary partitions, where your operating system and data are stored, and a recovery partition used by the operating system to store recovery files. TPM and GPT serve different but complementary purposes in modern computing. TPM enhances security by storing encryption keys and ensuring system integrity through secure boot. GPT is about how data is organized on the disk and ensures that modern disks are partitioned correctly and efficiently. For example, on a UEFI-based system, secure boot, enabled by TPM, can ensure that only signed bootloaders from a trusted source are executed. Meanwhile, GPT enables the system to use a UEFI-compatible boot partition, such as the EFI System Partition, to load the OS. In summary, TPM is a hardware security chip that provides encryption and system integrity features, like secure boot and disk encryption. GPT is a modern partitioning scheme that allows for larger drives, or partitions, and better data integrity compared to the older MBR partitioning system. Together, they contribute to the security and efficiency of modern computers by ensuring safe booting, data encryption, and proper disk management.